Okay, let us go with the last case. Roots of lambda square plus a lambda plus b equal to 0 algebraic equation with imaginary part different from 0. And we remember that if lambda is a root with imaginary part different from 0, then lambda bar is a root 2. When I say complex here in this part, I mean complex with a non-trivial imaginary part, because real numbers are complex numbers too, so I have to specify this. Here we just apply the formula, but we take an example as usual. And we start from an example, and through the example we will understand everything, but I want to give you a proposition. So let a function z of t be a solution to the linear equation, linear homogeneous equation with constant coefficients, y second plus a y prime plus b y is equal to 0. And z is a complex function. If it is a complex function, then the real part of z of t is equal to z1 of t, and the imaginary part of z of t, that is z2 of t, are solutions to the same equation that we call here asterisk. And proof. It is very simple. We have that since z is a solution, we have z second plus a z prime plus b z, which is equal to 0. This means that z1 second plus a z1 prime plus b z1 plus I z2 second plus a z2 prime plus b z2 is equal to 0. So remember that two complex numbers are the same if and only if their real and imaginary parts are the same. So we conclude that z1 plus a z1 prime plus b z1 is equal to 0, and z2 second plus a z2 prime plus b z2 is equal to 0. Okay, this is the proof. Now, as an example of applying this thing here, consider the equation. So the example, the exercise is find the general integral of the equation y second plus 2y prime plus 3y is equal to 0. So go immediately to the associate algebraic equation is equal to 0. So lambda 1, 2 are equal to minus 1 plus minus 1 minus 3. So it is minus 1 plus minus I square root of 2. Okay. Then, extending the recipe, we have that two solutions of the differential equation of the ODE we are considering. Extending the recipe for a real solution to complex solution, we use the exponential. We have that z1 of t is equal to e to the minus t, e to the I square root of t, and z2 is equal to e to the minus t, e to the minus I square root of t. Namely, by the definition of complex exponential, this is e to the minus t cosine square root of t plus I sine square root of t, square root of 2t, and z1 e to the minus t cosine square root of 2t minus I sine square root of 2t. So using the proposition, using previous proposition, the function, the real functions here we have y1, which is the real part of z1, which is e to the minus t cosine square root of 2t, and y2, the imaginary part of zeta1, which is minus the imaginary part of z2. Sorry, I'm putting some square root in an absurd fashion. E to the minus t sine of square root of 2t are two linearly independent solutions to asterisk. So, by the theorem on the structure, of the general integral for linear homogeneous ODEs, we have y gen of t is equal to c1 e to the minus t cosine square root of t square root of 2t plus c2 e to the minus t sine square root of 2t. This is y gen. And then the general rule is the following. If the algebraic equation lambda square plus a lambda plus b equal to 0 has no real solutions, namely lambda 1, 2 is equal to lambda prime plus minus I lambda second with lambda prime lambda second in R, then y gen of t is equal to c1 e to the power lambda prime t sine of lambda second t plus c2 e to the power lambda prime t cosine lambda second t. And this is all for this case. And now the very last part is how to guess yp. I give you some particular cases. And so we start from the equation y second plus ay prime plus by is equal to f of t. So first case, if f of t is equal to Pm of t e to the mu t. Here Pm of t is a polynomial of degree m. Then A, first point, 1A. We have to distinguish two cases. If mu, this is the generic case, is not a solution of the algebraic associated equation, which is also called characteristic equation sometimes, then the guess is the following. Yp of t is equal to qm of t e to the power mu t, where qm here is a polynomial of degree m, like p. This is very important. The coefficient, whose coefficient are to be put there, are to be considered as unknown. This is point A. Second, point B says f mu is a simple solution. So multiplicity equal to 1. So is a simple solution to the algebraic equation then yp of t is equal to t qm e to the power mu t, where here this is a polynomial of degree m. Again, so you have just to multiply by t here, very simple. And then the last case, if mu is a double, which means multiplicity 2, solution to the algebraic equation, then yp of t is equal to t squared qm of t e to the mt, and again qm is a polynomial of degree m, like in the previous cases. Then here you have to put t squared in correspondence of a double solution. Then we go to the second cases. If f of t is equal to pm of t e to the power mu t, and then there is some alpha cosine mu t plus beta sine mu t for some a b real, so alpha beta real, then again there are some cases. The cases here are only two. A, if m plus I nu, mu plus I nu is not a solution to the algebraic equation, now you have to check mu plus I nu, because here there are trigonometric functions to the algebraic equations. then the guess is yp of t is qm of t e to the mu t cosine of nu t plus rm of t e to the mu t sine of nu t. And here again q and r are polynomials of degree m. While here, the second case is that if, again, mu plus I nu is a solution to the algebraic equation, then yp of t is equal to t qm of t e to the mu t cosine of nu t plus t rm of t e to the mu t sine nu t. And again q and r are polynomial qm rm, polynomials of degree n. And this is all. There is another chapter I want to give you, because in my opinion it is not a chapter, it's just two words on what is called in many areas of science a superposition principle. That this holds for every linear equation. And there are two cases in which this is invoked. First, superposition of solutions. This holds for linear homogeneous equations. It is important that here they are homogeneous. So, if you have y1, y2, the solutions to the homogeneous equation y second plus a y prime plus by equal to 0, and you can have also a equal to at, b equal to bt, then y1 plus y2 is again a solution to the same equation. Sum of solutions is a solution for linear homogeneous equation. Coefficients can depend on time. Indeed, proof is very simple. Indeed, you take the sum and plug it into the equation. This is what you obtain. Then exploit property of derivatives, and the sum mounts into y1 plus a y1 prime plus b y1 from one side, and plus y2 second plus a y2 prime plus b y2, and this is equal to 0 here and to 0 here, because the two are solutions, so this is equal to 0. And analogously, you have that if y is a solution to the same equation, to y second plus a y prime plus c y is equal to 0, then ky, for every real k, is a solution too. I leave it as a homework. So, generally speaking, given two solutions, y2, to the usual equation we are studying, then every linear combination, start getting familiar with this idea of linear combination of the two solutions. So y equal to lambda y1 plus mu y2 for every lambda mu real is a solution too. This is a very powerful observation in order to build up solutions from already known solutions. And the second is about superposition of effects, and this is very important too. This time are non-homogeneous equations. You have these two equations, y second plus a y prime plus b y is equal to f1, and 1 second plus a y prime plus b y is equal to f2. This is equation 1, this is equation 2, and f1, f2, a, b, r can be functions of t. They can be constant or not in time. Then you have y1 solution 2, 1, and y2 is a solution to 2. Then y1 plus y2 is a solution to y second plus a y prime plus by is equal to f1 plus f2. This is very useful when the source is given as the sum of many terms. For instance, if you have y second plus a y prime plus by is equal to 1 plus sine of t, for instance, and you have, and in order to find a particular solution yp, this will be 1 p1, 1 p2, where yp1 is a particular solution to the equation with the same homogeneous part, but only one as a source term, and yp2 yp2 prime plus b yp2. This is equal to sine of t. This is physically very expressive, that I'm saying if there are systems, linear systems, like for instance also electromagnetic system, if you put one source of electromagnetic field and then another source, the electromagnetic field that you obtain at the end is the sum of the electromagnetic field that you would obtain if you just put one as a source, plus the electromagnetic field obtained by the source here. What are linear theory? The most important theory is linear, which is quantum mechanics. So perhaps the world is linear. So, and this is a good conclusion for a course, even though I will charge another, in my opinion, important lecture for you. Not for the course of analysis, not really for analysis 1, a bit for analysis 1, but for you, for physics 1 and mechanics, which will be about oscillators. Thank you very much for attention. the way was a new way with this new method. I hope that it will be not so bad. It was not good because it was a way of keeping us alive in these historical brackets. I hope that these brackets are almost at the end, and that your colleague of the next year will see each other, not only see the teacher, but see each other. Okay, thank you, goodbye, see you at the exam, and there will be this harmonic oscillator probably next week. Goodbye, and we will see at question times, of course.